If you think the AI revolution is what you're seeing today with large language models, well, I've got some news for you. That's just the opening act. We are right on the edge of three fundamental shifts that are going to redefine not just artificial intelligence, but computing as we know it. So let's break these down and see where the future is really headed.
Okay, this is at the very heart of AI's biggest problem, 21 megawatts. That's how much power it takes for Frontier, the world's top supercomputer, to train those massive AI models we hear about all the time. To put that in perspective for you, that's enough energy to power over 15,000 homes.
And this is where things get truly mind-boggling. You see that 21 million watt supercomputer? Now look at the human brain. It achieves roughly the same amount of computational power using just 20 watts. Yeah, 20. Barely enough to light up a dim light bulb. Our brain is, quite literally, 1,000,000 times more energy efficient. And that staggering gap is the brick wall the current AI boom is about to slam into. Overcoming it is what this is all about.
So here's the journey we're about to take. We're going to start with AI's unsustainable appetite. Then we'll explore three game-changing solutions, making AI smarter, not bigger, creating an AI that actually does things, and the seriously mind-bending idea of a living computer. And to wrap it all up, we'll tackle the big question of control with the governance gauntlet.
You know, for the last few years, the whole mantra in AI has been bigger is better. Just throw more data, more parameters, and more power at the problem. But this endless scaling is creating a massive energy crisis. The costs, both computational and environmental, are just getting so high that building bigger and bigger models is, well, it's just not going to work anymore.
All that inefficiency is forcing a huge shift in thinking. So instead of just chasing pure size, the smartest companies out there are now building smaller, much more efficient, and highly specialized models. Think of it as a move from pure brute force to something with a bit more finesse.
Now let's be really clear here. Right-sized AI does not mean weaker AI. It's about training a model to be a true expert in one thing, instead of being a jack of all trades. A perfect example is Microsoft's new 5.4 model. It's tiny compared to the giants, but it rivals much larger systems on really complex stuff, like mathematical reasoning. It just proves you don't always need a sledgehammer to crack a nut.
So how is this even possible? Well, companies like DeepSeek are pioneering some incredible engineering. First, they use what's called a mixture of experts architecture. The best way to think about it is like a giant library. Instead of reading every single book for an answer, the AI just pulls the one expert book it needs. This means only a tiny fraction of the model is active at any time. On top of that, they use clever tricks to pass down wisdom from bigger models and even optimize code right down to the hardware itself.
Okay, so why should you care? Well, first, it's just better for the planet. A smaller carbon footprint for our AI tools. Second, less waiting. This means faster, more responsive chatbots that don't leave you hanging. And third, and this is a big one, way better data privacy. See, because these smaller models can run right on your phone or laptop, your personal data never has to leave your device.
So now that we've made AI more efficient, the next revolution is all about making it more useful. We are moving from an AI that just talks and gives you information to an AI that can actually take action and get complex things done for you. Welcome to the world of agentic AI.
Here's the best way to wrap your head around it. The AI we have today is like a cookbook. It can give you a recipe. An agentic AI, though, is like a personal chef. You tell it you want lasagna, and it figures out a shopping list, orders the groceries, and then cooks the meal. It understands a goal, it makes a plan, and it uses tools to get the job done. And this is not science fiction. It's already starting to happen. The impact is being felt everywhere. In healthcare, these AI agents are helping automate drug discovery. In manufacturing, they're optimizing these incredibly complex global supply chains. In science, they're literally designing and running experiments, speeding up discovery in ways humans just couldn't do alone. This isn't just about convenience. It's about completely changing how complex work gets done. We've talked about making silicon smarter, more capable, but the most radical solution to AI's energy problem, it asks a totally different question. What if the computer wasn't made of silicon at all? And that question leads us to maybe the most futuristic and profound evolution in computing ever. We're talking about harnessing living biological neurons. Yep, actual human brain cells to perform computation. Welcome to the frontier of biocomputing.
Right now, researchers are developing something they call organoid intelligence, or OI. They are growing these tiny, three-dimensional clusters of human brain cells in a lab. They call them organoids. And they're learning how to use these mini brains as biological processors, tapping directly into that unbelievable efficiency we talked about at the beginning.
The advantages here are just staggering. First, the energy efficiency is, like we said, millions of times better than silicone. Second, they're naturally scalable. They literally grow on their own, which is a lot simpler than building a massive complex chip factory. And third, they are built for continuous learning. A silicon chip is rigid, but a brain organoid is constantly rewiring itself and adapting, just like a living brain.
So, how does it actually work? Well, one of the key techniques is called reservoir computing. Scientists feed a signal into the brain organoid, and it acts as this dynamic reservoir. The organoid's neural network processes that signal in this incredibly rich, complex way, and external AI then just reads the output. The living tissue does all the impossibly hard work, and the AI just interprets the result.
So, let's take a breath. We have AI that is smarter, more autonomous, and, potentially, alive. This absolute explosion of capability brings us to our final and most critical challenge. As all this new power emerges, who is actually in control, and who gets to write the rules?
The race to regulate is already on. This quote about the EU's AI Act is really important. Remember how their GDPR data privacy law basically became the default standard for the whole world? Well, the EU's new rules on AI could have the same global impact, shaping how AI is built and used everywhere. And these regulations aren't about slowing down chatbots. They are focused squarely on high-stakes AI, the kind that controls critical things like our power grids, operates self-driving cars, applies physical force, or performs mass surveillance. These are all areas where an AI making a mistake could have direct and very severe consequences for our safety and our rights.
Which brings us to our final thought. We've seen AI evolve from this energy-hungry behemoth into something smarter, more capable, and maybe even biological. Each step brings incredible promise, but it also brings these profound questions about control and ethics and who's in charge. So the question I want to leave you with is this. As AI becomes more powerful, more personal, and even biological, who do you think should be writing the rules?